Okay, so on to part 6 proper, which is just after the graph. One of the things that we need to do is calculate the final value that we're after from our gradient of our graph. But we're also going to need the errors in that. So what this part does is, it, as well as work out the gradient of the graph, it also, if you zoom out a little bit so that you can see, but you can look at the proper document, we also apply a maximum and minimum gradient to the same line. Now what this means is, we take the line of best fit, which goes bang through the middle of all the error bars, but we fit to that a maximum, so a sort of a most sloped or a least sloped. You can do both, you don't necessarily have to. But sometimes it's a nice idea to do both. They not always come out exactly the same. So sort of the steepest and the least steep line of best fit that you think you can get away with. And you can also work out a gradient from each of those as well. So this is what we refer to as a max and min gradient. Now you can see the way that if the error bars were bigger, those max and min lines would be further away from the original. Or if we had more scatter, if the results were a bit more all over the place, the same would apply. And therefore the error in our gradient, the possible variance, essentially the range our gradient could take, would be a lot bigger. When the graph, when the results on the graph are quite good and they're quite close to the trend line like this, there's not very much variation in where that trend could be, so the error in the gradient is quite small. So this is a good way of using the error bars to sort of reflect, or the errors in the points that you've plotted will influence and reflect on the final values that you get from calculating what is more often than not going to be the gradient. If you were doing an experiment that revolved around working out the y-intercept, though, the effect would be the same. The bigger the scatter, or the bigger the error bars, the greater the difference in the placement of the lines, and the bigger the variation in your value of y-intercept that you could potentially get.